Complex numbers. We have a new definition in this section, an imaginary number. Remember when we looked at things before, a square root of a negative number? We said that it is non-real, but this does occur fairly often, so we're going to have a definition for it. So the square root of -1 is equal to I. The I works in a cycle of 4. So square root of -1 is I. If we do the square root of -1 times the square root of -1, it will take the radical off. So this is I times I. I squared is equal to just -1. So it goes back to a real number at I squared. Right? If you did one more to have 3, here you have I squared, which is -1, times I. So I to the third is -I. And if we had 4, square root of -1, 4 times, this will give us -1. These two will give us -1, and -1 times -1 will give us a +1. So this one also goes back to a real number if you have I squared or if you have I to the 4th. If A is a positive real number, then the square root of -A is equal to the square root of -1 times the square root of A. So when you have the square root of a negative number, you are going to pull the I out first. So it will give you I times the square root of A. We have 4 problems here that we will simplify and express in terms of I. So the first thing we have to do is pull out that square root of -1 times the square root of 9. This is our I, and 9 is a perfect square. So here is our I times square root of 9 is 3, or 3I. For the square root of -17, we will pull out the square root of -1 times the square root of 17. This is our I. There's nothing you can simplify with the square root of 17. 17 is a prime. It does not break down. So you can write it as I times the square root of 17, or you can switch your order. Just make sure that you don't put the I back under the radical. It's okay to have it after or in front, but don't leave it underneath the radical. For our next problem, 5 times the square root of -20. We're going to keep the 5 on the outside. We're going to take out the square root of -1, which is our I. And we have square root of 20. But 20 is going to simplify. We can break it down. 4 times 5, you might see right there that you have a square. If so, go ahead and take the square root, which is a 2. If you don't see it, go on to primes. And then there would be your square. Right. So this 2 is going outside. It's going to multiply by the 5. So we have 5 times 2 is 10. I times the square root of 5. For our next problem, square root of -24 x squared. We do have an I to take out. Also, we can take the square root of x squared, which will be x. So we have the square root of -1, which is our I, times the square root of 24. And it's times the square root of x squared. We can go ahead and take the x out if we want. So we have I times x. And for 24, we can break it down. So we want to find a square in there. The 4 is a square. We can take the square root. It's a 2. Or you can keep breaking to primes. And when you find 2 copies of something, that's your square. So this 2 is going to the outside of the radical, along with our x. And 2 times 3 will go back underneath to be a 6. The I, you can write it here, 2xi, or you can write it after the radical. So you have some choices of how to write it. Remember when we were first looking at multiplication of radicals and also the simplifying, the square root of a times the square root of b is equal to the square root of ab. This is only if a and b are both non-negative real numbers. So if we have negatives in there, we can't use this rule. We will have to take out the square root of -1 or the I before we try to multiply. So on our square root of -6, that is the square root of -1 times the square root of 6, which is an I, times the square root of 6. And we're multiplying by the square root of -3. So we'll take out the square root of -1, which is our I, and it will leave square root of 3. So our I times I is I squared, which remember is -1. We have the square root of 6 times the square root of 3. You could multiply those right away and get square root of 18, but it's going to break down. Or you could just put them under the same radical and break them as you go. For 6, we have 2 times 3, and we have another 3. This gives us a square. So a 3 can go outside. It's going to multiply by the -1 out there. So it will be -3 times the square root of 2. Next, we have square root of -8 times square root of -6. We have to pull those i's out before we can do anything else. So we have square root of -1, which is our I, times the square root of 8. And we have a square root of -1 here, times the square root of 6. This will give us another I, so we're going to have I squared. So I squared, remember, gives us -1. We have the square root of 8 times the square root of 6. We will write them together underneath. And let's just break them down rather than multiplying and getting 48. That's kind of big. So if we break them down, we've done 8 a few times. It gives you 3 2's. And 6 is 2 times 3. Don't forget your -1 there. And so now we look for squares. So there is a square, and here is another square. So we're going to take a 2 out and a 2 out. That will give us 4 times -1 is -4 times the square root of 3 is our answer. For this problem, first we should take care of that I. So we'll pull the I out. So square root of -1 times the square root of 125 over the square root of 5. I would put these back under one radical because they have something in common. They have a 5 in common. So we're going to have our I on the outside. Put these back together. 125 divided by 5. You can simplify underneath, and 5 will go into 125 25 times. 25 is a perfect square. It is 5. So this will give us I times 5, or 5i is more common to see. For our next problem, we have an I to pull out in the numerator and denominator. So we have our square root of -1, which is our I, times the square root of 12. And down here we also have our square root of -1 times the square root of 6. These will divide out because they're just alike. And these two can go back as one radical. They have a common factor. That's your clue that you want to do that. And 12 divided by 6 is 2. So we have just the square root of 2. We have another definition, and this is a complex number. A complex number is of the form a plus bi. A and b are real numbers, and the I is imaginary. So A is called the real part and B is called the imaginary part because it has the I. The standard form, and this is how you will often be asked to write your answer, is A plus BI. For the next few problems, we will write in this standard form A plus BI. So we're going to simplify. On this one, first we'll simplify our radical. So we'll pull our I out. So it's I times the square root of 9. And the square root of 9 will give us a 3. So we can rewrite this as 7 plus 3i. That is in the standard form, A plus BI. For this next problem, first I would work on simplifying that square root of negative 18. So if we keep 12 plus, you can take your I out, I times the square root of 18, we're still over 6. 18 has 9 times 2, and 9 is a perfect square, which would give us 3 on the outside. So we have 12 plus 3 times I, or I times 3, 3i times the square root of 2, all over 6. Now, to get to standard form, we will break this apart, putting each piece over that denominator. So we have 12 over 6 plus 3i square root of 2 over 6. 12 over 6 will reduce to 2, and this will reduce. 3 will go into 3 once, 3 will go into 6 2 times. So I times the square root of 2 over 2, to be in standard form, we'll switch the order. So square root of 2 over 2 times I. We have 2 minus the square root of negative 125 over 10. We'll simplify and write in standard form. I would first work on this radical. Take out your I. So I have 2 minus I times the square root of 125. And we are over 10. 125, we'll just break it on the side. But we have 5 times 25 in there. And 25 gives us a perfect square. You can go all the way to primes, or if you realize it right here, you could take the 5 out. So for a group of 2, 1 will go out. So we have 2 minus I times 5 times the square root of 5. 1 is left. All over 10. And now we can go ahead and break it apart. Put each one over that 10. So we have 2 over 10 minus I times 5, or 5i over 10, times the square root of 5. Right. 2 over 10 we can reduce. 2 will go into 2 once, 2 will go into 10 5 times. So we have 1/5 minus 5 will go into 5 once, 5 into 10 will go 2 times. So we have a half times I times square root of 5. So the 1 times square root of 5 we can put together to just be square root of 5 over 2, and we'll put the I last to be in standard form. So 1/5 minus square root of 5 over 2 times I.